So for this first lesson, we're going to be talking about adding and subtracting rational numbers. Remember, anything that says rational in it, you think of the word ratio, and hopefully that keys you into that it can be written as a fraction. Rational numbers are not always written as fractions, but they can be written as a fraction. So if you see ratio, that's your hint. Okay, for our warm-up, just adding and subtracting some numbers. These are technically rational because 5 can be written as 5 over 1. However, you probably think of these more as being whole numbers or when they're negative integers. So for our first one, we have 5 plus negative 3. And what hopefully you remember is that adding a negative is the same thing as subtracting a positive. So what that means is 5 plus negative 3 is the same thing as 5 minus positive 3, or 5 minus 3. And to me, 5 minus 3 looks a lot easier than 5 plus negative 3, and 5 minus 3 is just 2. Down here, 14 minus 20. 14 minus 20 would give you negative 6. Remember, if you have a positive number and you subtract a negative number, or you subtract a number bigger than it, you're going to end up with a negative number. Down here, negative 12 plus negative 4. I always say this time and time again, so hopefully it'll stick in your head. Adding a negative is the same thing as subtracting a positive. So negative 12 plus negative 4 is the same thing as negative 12 minus 4. Negative 12 minus 4 would give me negative 16. Here's an easy one. 14 plus 3 is just 17. Negative 15 minus 9. Remember, when you subtract a number from a negative number, it will stay negative. So negative 15 minus 9 would give me negative 24. You can kind of think of this as just adding these two numbers together and putting a minus sign in front. Last one, 1 plus negative 19. Hopefully you get this by now. Adding a negative is the same thing as subtracting a positive. 1 minus 19 would just give me negative 18. Hopefully all this was just a quick, easy review for you. You should already know all that. So when we're comparing rational numbers, remember, rational numbers can be written as a fraction. Ratio, here we see they actually are fractions. So we're going to have two different methods of comparing these rational numbers. Method one is my favorite way, so if you want to put a star by it, okay, finding a common denominator. This is easier in my opinion, and it's a lot easier to do in my head. So I want to find a common denominator. I have my denominators. Remember, denominators are the bottom numbers of fractions. I have 3 and 6. Whenever you want to find a common denominator, the easiest way to do it is to take your two denominators and then just start listing factors. So like multiples, sorry, not factors. List the multiples. So for example, for 6, the multiples of 6 would be 6, 12, 18, 24. You're just adding 6 every time. For 3, it would be like 3, 6, 9, 12. And what I want to do is find a common denominator. Well, I can see each of these have a 6 in them, which means 6 is going to be my common denominator, which means I want to write both of these as having a denominator of 6. Well, 5, 6, that already has a denominator of 6. That one's done. What I need to do is change 2/3 to somehow have a denominator of 6. And hopefully you remember that the way to do that is you have to multiply the numerator and the denominator by the same thing in order to change a fraction. So I somehow want to get 3 to 6 by multiplying. Well, hopefully you remember 3 times 2 is 6, and I will be using a dot for multiplication. So just know that instead of using a multiplication sign like we used to, I'm going to always use a dot, because we're going to use the variables a lot, and that looks like an x to me. So here's going to be your sign for multiplication. So 3 times 2 is 6, but if I multiplied my denominator by 2, I have to multiply my numerator by 2 as well, and I get 4 6. And what this is telling me is that 2/3 is going to be the exact same fraction as 4 6, because I multiplied numerator and denominator each by 2, so these are equivalent fractions. So now I know that 2/3 is 4 6, and I want to compare these. Which one's bigger? Well, if you have the same denominator, all you have to do is look at the numerator. So we found a common denominator. We used our first method. Now I just look at my numerator. Which is bigger, 4 or 5? 5 is bigger, which means that 4 6 is less than 5/6. This fraction on the right is bigger, and we know 4/6 is the same thing as 2/3, which saying 4/6 is less than 5/6, I can now say 2/3 is less than 5/6. And this looks like a lot of work, but hopefully you can find a common denominator in your head most times. I'd even be okay if you converted it in your head, but I would like you to show your work for now. And then you just compare the fractions. So 2/3 is less than 5/6. How did we figure that out? We found a common denominator and we compared those two fractions. Our second method is convert them to decimals. And this is the way that you probably are going to like. I don't like it as much because I don't like working with decimals. Okay, so this is your other method, convert to decimals. What you would do, you'd see what's 2/3 as a decimal. Well, that's 0.6 repeating. And then you'd see what is 5/6 as a decimal. Well, that's 0.83 repeating. And now I'm going to compare 0.6 to 0.83 repeating, and 0.6 repeating and 0.83 repeating. And obviously 6 in the tenths place is less than 8 in the tenths place, so it's going to be less than, which hopefully you already knew that this was going to be less than, because we showed last time 2/3 is less than 5/6. Once you know the decimals work this way, 0.6 repeating is less than 0.83 repeating, you know that 2/3 is less than 5/6. You're probably saying, oh wow, this is so much easier, all I had to do was type it into my calculator. And it may be faster right now, but sometimes these decimals can get pretty sloppy and they can go out a long time, and it's just easier to find a common denominator instead of working with repeating decimals all the time. So you can use method 2 if you really want to. I would much prefer you to use method 1. So looking at our first example, we're going to order the numbers from least to greatest. And to do that, we somehow need to compare all these numbers. And I just finished saying method 1 was my favorite. However, use method 2 if one of them is already a decimal. This one's already as a decimal, so we're just going to use method 2 because otherwise we'd have to convert from a decimal back to a fraction. So 5 2/9, to figure out what that is, just type it in your calculator. 2 divided by 9. 2 divided by 9 gives you 0.2 repeating, and I already know the whole number is 5 because it's 5 2/9. So 5 2/9, it's going to be 5 and then whatever 2/9 is, and we know 2/9 equals 0.2 repeating. So it's 5 2/9 or 5 and 0.2 repeating, so it's 5.2 repeating. So 5 2/9 is 5.2 repeating. And hopefully this is a review for you, so I'm not going to show all the work for these. 5 3/8 is 5.375. 4.9 is 4.9. Negative 5 3/5 is negative 5.6. And now I'm just going to order them from least to greatest. To do that, I pick the smallest one. If you think 4.9 is the smallest one, you are wrong because we have a negative number. Negative numbers are always smaller than positive numbers. So we start out with negative 5.6. And hopefully this didn't trick you because you're already getting tricked on example 1. That's not off to a good start. But if you did, it's probably okay. You're still getting used to being back in school from summer. Now we look at which one of these is the smallest of my positive numbers. Now you can use the 4.9. Then, which is smaller, 5.2 or 5.375? 5s are the same, so we look at our tenths place. 2 is smaller than 3, so 5.2 repeating is smaller. And then my biggest number is 5.375. And all we did, we converted them all to decimals, compared them, and ordered them from least to greatest.